Okay, in this tutorial we'll talk about code tracing. Now, what is code tracing? Code tracing is simulating program execution by tracking and updating variable values by hand. And this skill can be very, very helpful, especially at the beginning of your programming learning journey. And it can be helpful in so many ways. One way is that it can help you understand how a particular program actually works, right? That's because when you have so many variables, okay, it can be very difficult to really keep track of all the different variables in your head, right? That's because these variables actually change simultaneously, and they can change in different ways, right? One variable can, for example, increase by 2 at a particular step. Another variable can be multiplied by another number. Another variable can be a part of a loop or a condition, etc., etc. So keeping track of all these different variables can be a difficult process, right? Another way code tracing can be helpful is when we try to troubleshoot a broken program. Okay, so what we do in that case is that we write the different variables down and we start mentally executing the program, and or until we get to the point where the program actually breaks. After that, we can rectify the mistake at that point, rerun our program, and see if we have gotten the results that we have expected from this program. Okay, so you can actually see from now how code tracing can be a very helpful skill, right? Now, let's take a look at this simple program and apply the code tracing method to see how it can actually help us. Uh, Now, let's first count how many variables we have in this program. We have the list1 variable, the list2 variable, we have the x variable here, we have the y variable here, and we have the z variable here. Okay, now since the first two variables won't change throughout this program, we won't be tracing them. Okay, we will be tracing is x, y, and z variables. All right, and please make sure that you understand which statements belong to which statements in this simple program, right? And you can figure that out by taking a look at the indentation of the different statements. Okay, so for the first for loop here, all of these statements will belong to it, right? For the second or inner for loop, only these two statements will belong to the for loop. Okay, that why? Because they are indented further from the header of the for loop. The header of the for loop is for y in list 2, for example. Okay, so make sure to know which statements belong to which statements. Another thing is to know that these for loops are called nested loops. It basically means a loop inside another loop. Okay, now let's see how this program will be executed and how the different variables will be updated throughout the process. All right, so let's write our variables down here. So we have x, y, and z. All right, initially, so for x, or after declaring the list1 and list2 variables, we have for x in list1. All right, so x at the beginning will contain the first element in list1, in list1, right? So that will be 10. All right, now we will get inside the body of the first loop. Now, what do we have inside the body of the first loop? We have this for loop and this print statement. So at each iteration of the first loop, we will be executing another loop. All right, so inside we have for y in list 2. Okay, so what do we have in for y in list 2? What will be the value of y at the first iteration of this loop? It will be 1, right? Now we get inside the body of the inner loop. So we have z equals x times y. What is x times y, it is 10. So z at the beginning will be 10, right? Next statement in the inner loop is print z. What is z? 10. So 10 will be printed out, right? Now, are we done? No, this loop hasn't finished execution, or the inner loop hasn't finished execution. So now y will change to 2, but x will remain as is. Why? Because we haven't, or the inner loop again hasn't finished execution. So it's important to know how these for loops actually work. So y now will be 2, and x will remain the same. All right, now z or now we get inside the body of the inner loop. Now we have z equals x times y. All right, what is x? 10. What is y? 2. So z now will be 20. All right, now print z. What is z? 20. Right? Are we done with the inner loop? Not yet. Now y will be 30 and x will remain 10. Sorry, y will be 3 now and x will remain 10. So z will be 30. All right, now we print z and the output will be 30. Right? Now that we are done with the inner loop, we will go to the outer loop and update the variable x. Right? Now x will move to the second value, which is 20. All right. At this point, we will go inside the inner loop one more time. At the beginning, y will be 1 again, right? Now z equals x times y, right? So it will be 20 by 1, and z will be 20. Now print z, and we will print out 20, right? Next, y will change to 2, right? And x will remain the same. So now z is x times y, 20 by 2 is 40. Next y will be 3, and we will repeat the same process, and z will be 60, right? At the last iteration, x will be equal to 30, and we will repeat the same process for y. 1, 2, 3. 30 by 1 is 30, 30 by 2 is 60, and 30 by 3 is 90. And we are done. This is simply how we can trace this particular program to see what the final output will be. In this case, this will be the output. Okay. Now, here is a cleaner version of the code tracing process on a white paper. As you can see, we have the x, y, and z variables, and we can see how at each iteration or at each part, x will remain the same and y will change, right? X will remain the same and y will change. X will remain the same and y will change. And here is the actual computer output after I have run the program using the Python language. As you can see, it's the same as the output that we have gotten when we did it manually. 10, 20, 30, 20, 40, 60, and 30, 60, 90. All right. Now you can actually, you may have been able to understand that program in your mind, but in certain cases, when you come across much more complex programs with much more variables, the process of tracing these variables will be daunting. All right, so code tracing can definitely help you in these situations. All right, so I hope you understood this skill, and I hope you start using it in the future to write better programs and to troubleshoot broken programs. Thanks for watching, and I'll see you in the next tutorial.